just today we started finding the domain and range of even roots. And it's pretty easy. I just have one thing I have a question on.
Okay.
Okay, so we're finding it without graphing.
Okay.
And the equation is the fourth root, I guess, of 3x squared plus 31x plus 56. And I'm just not quite sure.
Plus what?
56. 56, yeah.
56?
Mm-hmm. I'm just not sure how to find the range.
Okay. Does this factor? Yes, it does. Let's factor that quadratic inside. What's the rest of it?
Okay. 8 and 7. Or plus 8 and then, so x plus 8 and 3x plus 7.
Is it?
Yeah.
I think it's this way, isn't it?
Yeah, like that.
8 times 3 is 24, 7 and 24 is 31. Okay.
Mm-hmm.
So, what's true about the domain?
It is, wait, what is the domain or what's true about it?
Yeah, well, how are we going to figure out the domain?
You're going to find the roots of this and then do the thing where you like do the graph. And
Sign chart.
yeah.
In other words, in order for this thing to be doable, because it's an even root, this times that has to be positive. Okay? So I can say 3x plus 7 times x plus 8 has to be greater than or equal to 0. That's the one condition that I know for sure. It can't be negative, the product. This could be negative and this could be negative, but the product can't be. So what are critical points?
Would it be, by critical points, do you mean negative 8 and
Yeah.
negative 7/3?
And negative 7/3, okay. Critical points are whatever makes these 0. If I was dividing by an x minus 5, then I would also have a critical point at x equal 5. So whatever makes either your denominator or your numerator 0 is a critical point. Okay? Now we draw our line chart, putting these 2 points on there. Now what?
I don't know, you draw your points. It's different from how I do it. Usually I just make a little graph sketch.
Well, this line chart is actually the only way I know how to solve these, especially if division is taking place. If I'm dividing this by another linear factor, you got to use a line chart. There's just no other way to do it. Let me take you through this line chart method. The idea is to test some point to the left of negative 8. So let's test negative 9. What is this when I have x being negative 9? That's negative.
Yeah.
That's negative. Therefore, it's positive. And by merely testing one point, I know that every point to the left of negative 8 results in a positive. You with me?
Yeah.
Okay. Check a point between these two numbers. About negative 7.
Okay.
And we don't care what these numbers are. We merely care what their signs are. In other words, when x is negative 7, that's negative. When x is negative 7, that's positive. So their product is negative. So everywhere in between those two critical points, the answer is negative. Last, check a point to the right of this. How about 0? Well, 0, that's positive, so everything to the right of that is positive. Now we have our solution for the domain. Since this product has to be positive, there's our solutions right there. In other words, x has to be less than or equal to negative 8, or x has to be greater than or equal to minus 7/3. And, excuse me.
Bless you.
They always come in threes. So, in other words, what is inside the radical sign is only positive if x is less than or equal to negative 8, or I mean it's only doable because it can be equal to 0, or x greater than or equal to minus 7/3. So there's your domain. Now, if you need to put that into interval format, then it would be minus infinity to minus. That 8 is my infinity backwards. Minus infinity to minus 8 with a bracket in union with minus 7/3 to infinity. So there's your domain. Okay? Range. Now, what is the range going to be?
No.
Well, we know for sure of one thing. It's greater than or equal to 0. It's like when you take the square root of x, the range is y is greater than or equal to 0. Now, what's the range here? Question is there any positive number that we cannot produce? I don't think so. So I think your range is all positives, or 0, greater than or equal to 0. In other words, are there going to be any values that you can't produce for y? That are, I know you can't get negative values, but could you get a plus 1/2? I'm sure you could. Is all I got to do is solve this to equal 1/2. And I'm always going to be able to do that. In other words, this 3x plus 7 times x plus 8, I can make equal to any number I want. Therefore, the fourth root can be any number I want, as long as it's a positive number. But let's say, can I make that 1/2? Well, yes, I could, because can this be equal to 1/2? Well, notice the way I would solve that, I would turn it back into a quadratic. I would put 0 on one side, and I would apply the quadratic formula to come up with the solution. And it does not matter what number I put there. I could put 117 there, and I'd solve it the same way. I would put it into the standard form of a quadratic, apply the quadratic formula, solve it. So,
Okay.
If this times this can equal any positive number, then I can come up with any positive number for the range. So the domain is the hard part here more than the range. This is a bit of an odd problem because usually it's the other way around. Usually domain is real easy. Ranges can be tough. If I said, what's the range of this? You'd be hard-pressed to answer. If I said, what's the domain? You'd say all reals except x equal minus 2. Domains are super easy. Ranges are harder. In other words, this thing might graph. It doesn't, but it could graph something like this. And notice how hard it would be to find the range. The only way to find it would be to go in there with a tracer on your calculator and figure out what that value is there and what that value is there, because the range is going to omit. The range would not have that gap in it. So range can be quite difficult to figure out. Okay, what else you got?
I think that's all I really need with this.
Okay.
I think I can do the rest of it on my own. So can we do some SAT practice for like the next half a bit?
We got through 20 on page 284. I'm not sure how we did that, because I don't see a page 284. What the heck happened? 284. I see a 283. I must have been guessing. We'll start here. We probably don't need to start at 1, but we've only got 13 minutes. Let's go ahead and do 1. And before you do 1, let me tell you there is a shortcut. There is a quick way to do it. See if you can find it. That's what my double dots mean. My double dots mean there is a fast way to do this. Obviously there's a slow way that can be daunting. If I have to solve this, got to multiply everything by x, and then I'm going to have a quadratic that's got fractions. Okay? So see if you can find, just stare at that for a little bit, and see if you can see what x has to be.
I don't know. I mean, I can solve it, but...
Well, that's going to be hard. In other words, this little shortcut's going to save you about a minute time, if you can spot it.
Could you cancel the 7s?
No?
On this one?
What's similar? Try to see something similar between this and this.
The 3 over 7? 3?
So what's x got to be?
7.
That's the answer.
Oh, wow.
But notice that is all you had to do is notice that, well, this is 3/7. If x is 7, that's going to be 3/7, and that'll be 7, and it'll be the same thing on both sides. And this truly would have been daunting to have to solve. I mean, I'll start by multiplying everything by 7x.
Okay.
Now, notice how complicated that is going to be to solve. It's 7x squared minus 28x, whoops, excuse me, minus 31x plus 21 equals 0. Now, I either have to figure out a very tough factoring problem, or I've got to plug it into the quadratic formula to solve for x. I'll get x equals 7 either way, but it's not going to be easy and it's going to take a lot of time. So spotting these little shortcuts is really worth, every time you see a problem, it's worth noticing whether there's a shortcut there. And sometimes you almost have to be looking for the shortcut to know it. Which means you have to look for a shortcut on every single problem, and it's, you know, that takes 10 seconds in itself. So let's look at number 2.
Sorry, there's a box across the street. My dog's going crazy.
What's A?
One second. Ow! Stop! Wait, b equals 5. Oh, it's not 3, 4, 5. So
You want to be able to solve right triangles quickly.
would it be d?
Yes. In other words, by quickly, I mean you don't want to go back to c squared equals a squared plus b squared. That's going back to the Pythagorean theorem, and then you got to work through all of that. Okay, what you want to know is that if you're solving a short side of a right triangle, it's always the square root of the hypotenuse squared minus the other side squared, which gets you immediately to square root of 21, the answer. Okay, number 3.
Oh man. You just have to guess and check? Oh,
Kinda.
40.
In other words, you have to, there is one result there that will disprove the statement that all we know that it's not correct, right? All numbers that are divisible by both 4 and 6 are also divisible by 8. That's a false statement. Which number proves that that's false?
12.
Right. Because 12 is divisible by 4 and 6, but it's not divisible by 8. So that's all the further we have to look. Notice that 24 doesn't disprove it. That's divisible by 4, 6, and 8. C, this doesn't disprove it because this isn't divisible by 6. This is not divisible by 6. This is divisible by 4, 6, and 8. So it doesn't disprove it either. So in other words, in order to disprove that statement, we have to find a number that's divisible by both 4 and 6 and not divisible by 8.
Okay. Cool.
Okay, so the area of that parallelogram is 168. What's the formula for the area of a parallelogram?
Isn't it like all the top and the bottom, or the top and the sides divided by 2?
Same as a rectangle. Base times height, the only difference is it's the vertical height. It's that height, not the slant height. Okay? So if the area is equal to 168, which is equal to 14 times the slant height, well, what else is the slant height relative to this circle?
Well, not the radius, the height?
It's the diameter.
Not the diameter?
The diameter of that circle. Okay? So, if I've got 168 equals 14 times the diameter of the circle has to equal 12, making the radius of the circle 6. What's the area of the circle?
36 pi.
Uh-huh.
Cool.
Probability problem. We'll end on this one. This is a decent one. Player spins the arrow twice and multiplies the two numbers. What's the probability of the product being even?
Oh man.
This is a number theory question more than a probability question.
Would it be 100?
Well, let's do it step by step. What does it take to produce an even product?
Either two even numbers or an even and an odd.
Okay, so we can do an even times an even, or an even times an odd. Both of those are even. The only one that's not is odd times odd. Okay? So, let's figure out the probability that we'll get an odd number, and we'll know that the probability of an even number is 1 minus that. Right?
Yeah.
Okay. For us to get two odds on two spins, what's the probability of getting an odd on the first spin?
I'm sorry. On the first spin?
You got 6 numbers we can fall on. 1, 2, 3, 4, 5, or 6.
Well, there's only 2 that multiply would be...
Hold on. So all we're looking for is an odd. How many odd numbers are there?
3.
Okay, so there's 3 out of 6. So there is a 1/2 probability of getting an odd on the first spin. We have to get an odd on both spins. There's also a 1/2 probability of getting an odd on the second spin. So the odds of getting 2 odds, well, I shouldn't have said that. The probabilities of getting 2 odds is the product of those two, which is 1/4. So what's the probability of not getting 2 two odds. In other words, of getting even odd or odd even or even even.
I'm so lost. All of that minus 1/4?
1 minus this. Remember with probabilities that if you only have two choices, they have to add up to 1. So
Yeah,
if the probability of getting two odds is 1/4, the probability of not getting two odds is 3/4. And that's all we have to do is not get two odds. And that's the easiest way to do this one. 3/4 is the same as E.
Okay, cool. Okay.
Okay?
I think I got that, yeah.
Sorry, I got to run, but I got a 7.
Okay.
All right?
Thank you.
You're welcome. I'll talk to you next week, Sarah.
Yeah, all right. Have a good night.
You too.